Since the dawn of the space age, humanity has developed numerous advanced technologies to enhance our study of the universe, our galaxy, the solar system, and to search for signs of extraterrestrial life. Hello, and welcome to Z. Please don't forget to subscribe and hit the bell icon. Consider this tiny pinprick of light in the cosmos. That's us. That's planet Earth. On August 25, 2012, 35 years after its launch, Voyager 1 exited our solar system. During its departure, it captured a photo of Earth from 3.7 billion miles away before shutting off its cameras to conserve power. Now in interstellar space, after 43 years and 4 months, the spacecraft continues to communicate via the Deep Space Network. Voyager 1 has revealed that interstellar space is far stranger than we anticipated. What have we discovered, and why is it so significant? In the summer of 1964, NASA devised methods to study the outer planets of the solar system. At the NASA Jet Propulsion Laboratory, engineer Gary Flandreau forecasted that by the late 1970s, a rare alignment of the planets, Jupiter, Saturn, Uranus, and Neptune, would occur, an event happening only once every 175 years. This planetary alignment would enable humanity to visit all 4 planets within a single mission. The trajectory changes at each planet would increase the probe's speed, allowing it to reach the next target. This gravity-assisted maneuver, or slingshotting, uses a planet's gravity to accelerate the spacecraft, saving considerable energy and time. For instance, a journey to Neptune could take just 12 years instead of 30. The Mariner Jupiter-Saturn project commenced in early 1972 with a budget of $360 million. In March 1977, a few months before the launch, the probes were renamed Voyager 1 and Voyager 2 due to the mission's significance. These Voyagers were equipped with reprogrammable computers, enabling researchers to alter programs and resolve issues in real time. On August 20, 1977, Voyager 2 was the first to be launched into space, 16 days ahead of Voyager 1. However, because of its longer trajectory to reach Jupiter and Saturn, Voyager 1 eventually overtook it. Since 1962, interplanetary missions have studied Venus, Mars, and Mercury, with missions lasting up to 3 years. However, these probes needed to endure long enough for the Grand Tour project at NASA, which required 2 probes to investigate the 4 gas giants: Jupiter, Saturn, Uranus, and Neptune. Later, it was suggested that Voyager 1 and 2 only visit 2 planets. Press reports indicated that only Jupiter and Saturn would be visited, thus reducing the project's overall cost. Experts examined over 10,000 trajectories before selecting 2 that would allow flybys of Jupiter's largest moon, Io, followed by Saturn and its largest moon, Titan. This route also provided the opportunity to proceed towards Uranus and Neptune. The possibility of extraterrestrial civilizations intercepting these probes intrigued researchers. American astronomer Carl Sagan and his team created a golden record containing 115 images in analog form, spoken greetings in 55 languages, various natural Earth sounds like wind and thunder, animal sounds like birds and whales, and diverse music from around the world with the message, "Hello from the children of planet Earth." Music. Which probe made the first planetary mission? Initially, the mission plan was for the Voyagers to operate for only 5 years, enough to study Jupiter, Saturn, its rings, and the largest moons of these planets. However, as the mission progressed, scientists' ambitions grew, and the Voyagers exceeded all expectations. On March 5, 1979, Voyager 1 was 173,983 miles away as it approached Jupiter, capturing images of its moons Io and Europa. Although Jupiter had been extensively studied, new photographs provided researchers with unseen perspectives and more information about these planets, as if they were newly discovered worlds. The new images of Io, Jupiter's closest moon, revealed yellow, orange, and brown surface colors, indicating volcanic rock. At least 8 active volcanoes were observed on Io, ejecting material into space, and stunning images of this were captured during Voyager's flyby. Io proved to be the most volcanically active body in the solar system. A little over a year after its launch, Voyager 1 approached Saturn on November 12, 1980. The mission exceeded expectations, allowing researchers to broaden their understanding of Saturn. 3 new moons were discovered: Prometheus, Pandora, and Atlas. However, the most significant achievement was obtaining new information about Titan, Saturn's largest moon. Titan is the only moon in the solar system with a thick atmosphere. Additionally, it was discovered that Saturn's upper atmosphere layers consist of 7% helium, with the rest being hydrogen. Voyager 1 also discovered Saturn's G-rings, disc-shaped plains composed of ice and dust. Another intriguing finding was Saturn's 6th largest moon, Enceladus, which reflects more solar light than any other object in the solar system due to its fresh, clean ice surface. Images showed its crater-filled landscape, suggesting geological activity beneath the surface that could provide heat for a liquid ocean. Voyager 2 also made remarkable discoveries. On July 9, 1979, it made its closest approach to Jupiter and captured an incredible photo of Jupiter and its moon Io casting a shadow on the gas giant. On August 25, 1981, after reaching Saturn, the probe photographed the planet's rings and moons. By this point, it was evident that Voyager 2 could proceed to Uranus with all its instruments functioning. NASA requested additional funding and directed the Jet Propulsion Laboratory to extend Voyager 2's mission to Uranus and Neptune. On January 24, 1986, Voyager 2 approached Uranus at a distance of 50,600 miles above the icy cloud tops, collecting data that revealed 2 new rings, 11 new moons, and recorded Uranus's surface temperature at a frigid -353 degrees Fahrenheit. Uranus rotates at an angle, with its magnetic field displaced from the axis and plane of other planets. The data showed that both of Uranus's poles have the same temperature, even though only one receives sunlight. Researchers deduced that the planet must distribute temperature in unique ways. Recently, while re-examining decades-old data, researchers noticed a 60-second jolt in Voyager 2's magnetic recording during its 45-hour convergence with Uranus. It was discovered that Voyager 2 flew through a plasmoid giant magnetic bubble, possibly carrying Uranus's atmosphere into space. All planets lose atmosphere into space, including Earth. However, there's no need for concern, as we have enough atmosphere to last billions of years. When Voyager 2 approached Neptune, researchers expected to see only darkness. NASA teams expanded the Deep Space Station's radio antenna in Canberra, Australia, to receive the extremely weak signals from Neptune. On August 25, 1989, Voyager 2 was 30,000 miles from Neptune, about 30 times farther from the Sun than Earth. Neptune receives only 0.01% of the sunlight that Earth does. In almost complete darkness, Voyager 2 began capturing mysterious photographs, revealing the blue planet's composition, including methane, 6 new moons, and 4 rings similar to Saturn and Uranus. The rings and Neptune's moons formed a complex, interconnected system. The probe also detected winds of 1,500 miles per hour around a previously unseen area on Neptune called the Great Dark Spot, a massive rotating storm the size of Earth. Both Uranus and Neptune are known for their strong winds, reaching supersonic speeds 10 to 15 times stronger than on Earth. Initially thought to be gas giants, Uranus and Neptune were found to consist of heavier substances in the 90s, leading to their classification as ice giants. Triton, Neptune's moon, is located to the planet's north and is the coldest natural body discovered by astronomers, with temperatures at a frosty -391 degrees Fahrenheit. Voyager 2 approached Triton at about 25,000 miles and discovered active nitrogen geysers. Triton was the last object Voyager 2 would encounter in the solar system before venturing into the unknown. What lies ahead for the Voyagers? Their interplanetary missions have provided astronomers with a wealth of knowledge and a deeper understanding of our solar system. Together, these probes made significant advancements in astronomy. Voyager 2 was the first to study the outer planets, Jupiter, Saturn, Uranus, and Neptune, and entered interstellar space in November 2018. When Voyager 1 entered interstellar space, its plasma temperature instrument had stopped working, but Voyager 2's instrument was still functional. Our sun does more than just provide light and warmth. It propels the entire solar system through space, encased in a bubble called the heliosphere, inflated by plasma from the sun and known as the solar wind. This bubble extends 11 billion miles from the sun, encompassing all 8 planets and beyond. Outside the heliosphere, in interstellar space, radiation levels and cosmic rays are significantly higher than within it. The sun's solar winds shield the entire solar system as it traverses space. The heliosphere stretches far beyond Pluto until it reaches the termination shock, where its motion slows abruptly due to the interstellar medium's pressure. Voyager 2 discovered that the interstellar medium is at least 54,000 degrees Fahrenheit, but the plasma is so thin and diffused that temperatures around Voyager 2 remained extremely cold. The Voyagers have embarked on supplementary missions to study the solar system's outer regions and interstellar space. These 2 probes are continually speeding through interstellar space, never to return to our solar system, with only the infinite expanse of space ahead of them. NASA's website provides real-time updates on the Voyagers' positions. They are moving further from Earth every day, reminding us to expect the unexpected. Our friends at Channel Perception recently released an exciting new video about NASA's plan to stop an asteroid. We found it fascinating, and we think you will too. Check it out.